There's people that are here for
Hey,
the
guys.
first time. And so welcome. There are people here that I've seen many times at our calls. And so welcome back. You know, having this collaboration, beautiful minds from all over the nation, or really the world, putting our minds together and elevating this industry is what we're suited to do.
Absolutely.
Um,
For any who didn't hear, I'm Jeff. I'm the head cultivator of Northern Terps in Maine, and very honored to be here.
Absolutely. Very glad to have you here, Jeff.
Thank you.
So for those who are new, let me tell you about how this call works. What we do is, prior to the call, we send out a questionnaire and we have you submit questions. You know, there's a lot of questions, so we have to prioritize. I try to prioritize based on, you know, what we haven't covered yet, or maybe what the topic is for this week or for this month. So I have to handpick it a little bit just because there are so many.
Sure.
But you know, I want to also introduce our researchers and our subject matter experts. It's hard to look through the list to see who's here, but we have a host of very intelligent people. We've got, you know, Doctors Riley Kurt, Miyabi Shields, Marcus Rogan, Matt Desk. Oh, there's Marcus. And so these are researchers, subject matter experts from around the globe who, you know, we want to have here at this talk, to where you can ask questions and hopefully we have some good answers. And if we don't, we can go find those answers and talk about them the next time. So that's not to say that other people here, there's not some very, very bright minds. I think I saw Dr. David Hawley sign in, PhD from Fluence. So there's some very bright minds here, not to say that our core research group is all that there is, because, you know, we're very excited to have all these folks on the line. But this is open source in action. And so this isn't possible without you guys getting on here, being willing to share, willing to learn, and really elevating this industry together and as a whole. So that's very exciting. And, you know, every call, this number grows. I think last month we were at 40 something that was able to join live. This month we're looking at 63. So very exciting. People can take the hardworking time out of their day to jump on and help each other out. So thank you all. A little bit of update on our side at the CRC. The PIP studies are going fantastically. You know, as mentioned before, we are on Rep 3 right now at our facility for these trials. And so these trials are in correlation or in conjunction with PIP horticulture. And we're looking at air velocity from overhead. So we're looking at different air velocity, no air, high and low. And so again, we're on our third replicate here. We're going to be announcing all of the results first at MJBiz, and then probably a couple of months after MJBiz, we'll have second rep for the experiment where we can actually publish. The results we're getting are pretty wild, you know, and as I said last time, much different than what I hypothesized was going to happen. But in short, you know, higher airflow when we're at 400 feet per minute, we're not maxing out. We're not damaging plants. So we're increasing yields, and we're causing transpiration increase. We're causing greater yields and greater elemental uptake. So very exciting, and all those details will come out. I know I'm just throwing a little bit of.
How high are the fans off the canopy at that velocity?
So it's the PIP V2 setup, and so it's,
yes, the racket, right?
Yeah, can fans that send it over, and so it's top down airflow that we're actually measuring.
Oh, all right.
Yeah,
that'll be very interesting.
Super interesting result. It's so excited to share the
Allison.
Yeah.
Did you expect that to damage the plants, like physically? Was that what you were expecting?
Yeah, I thought there would be at least at the set points we were using, I thought there would be an upper limit to where, you know, you're causing wind burn, you're causing excess transpiration, which can cause problems. I don't feel we've hit that upper limit yet with the variable, or with the set points we're using. So we'll see.
Have you
the-
analyzed cannabinoid terpene content based on? Nice.
Yep. All sorts of stuff. We're looking at actually measuring elemental content, SPAD readings, height, difference of temperatures of canopy due to the different airflow, trying our best to capture as much data as we can for this.
Wonderful.
So
Hey,
water
Allison.
use efficiency is a huge one. There's Anders right there, my partner in crime from PIP.
I think for everyone on this call, what's interesting is when you go to indoor facilities across the United States, the average airflow most growers are achieving is somewhere between 100 to 200 feet per minute, which is 0.5 to 1 meters per second. And that's generally acceptable for most crops. But because cannabis is such a high light crop with such a fast transpiration rate, the hypothesis was, can it take more than that 1 meter per second? And so the 400 feet per minute that we've been applying to one of these rooms is more than, I would say, the industry average. And so that's what we were really curious to see is, will there be a beneficial response or negative impacts to plant health? And we saw a good response. And so that was, and we'll, as Allison noted, we'll be sharing more of what those benefits were at MJ Biz. But it was exciting to see. And that top-down airflow was also an interesting thing because of that mechanical resistance applying to the apical portion of the canopy, provided that response to keep, ideally hope to keep plants a little bit shorter and limit that stretch.
Really? So morphological changes.
Absolutely.
Awesome.
So that's one of the things we're doing. But like I said, we will be at MJ Biz this year. I've got a couple of talks, some booth meetups and things like that. So we'll send out more emails when it gets closer to time. Would love to see all ya and connect, however we can. Another update of some research we're doing just started is mother stock experiments. I love mother stock production and propagation. So this one's really fun. But it's in correlation with BIOS, and I'm sorry, not BIOS. It's in correlation with Saloom. They have adjustable spectrum lights, and so something we're looking at is same PPFD, same intensity, obviously hours per day, all the same. But what we're substituting in is a little bit of far red, and so seeing how far red on mother stock production affects the growth. Internodal spacing. And then, of course, if we're saying that mother stock should live for 3 months, looking at 90 days, those last 3 weeks of production within that 90 days, actually sticking the cuttings and seeing, does that far red application have any sort of effect on rooting? So
is it an all-day contribution or just a sunrise sunset sort of thing?
All day.
Yeah. Because we built out some custom far red bars in an attempt to gain the benefits of high pressure sodium, but have the efficiency of LED.
Mm-hmm.
And a lot of these companies do try to put as much red as possible in there.
Right.
So we've been looking at maybe adding a little more blue and seeing what that does to the, how they grow, how they stack, etc.
Absolutely. Yeah. So much to learn. But we'll see how that goes. I think we're on week 3 right now, so still pretty early on, but we'll show you some updates along the way. Last little update / question I've got is, let me put this link in the chat. So this is a paper that was just put out, gosh, I don't know, within the last month. And it's something that I've been playing with and have been really excited about for as long as I've been in cannabis. In poinsettias and mums, we've got a really good handle on daylight hours and how we should be doing short days and long days, and sort of the tools you can have by not just sticking with your 12-12. And so there's lots of tricks and tips we can do with photo period. But looking at this study specifically, what it really does is during the last 2 weeks, 1 to 2 weeks of your flower cycle, you're applying long days, which seems, to those of you who haven't dug through, the literature and photo period, it seems wild and crazy, and you're going to ruin your plants. And if you do it for 2 weeks on some varieties, or certainly over 2 weeks, you're going to have, they're going to throw hermaphroditic flowers. They're going to look weird and foxtaily. But there is that sweet spot, really proven by the research we've done here, by this peer-reviewed paper that was just put out, and by lots of facilities that I've seen already doing it, applying, a safe time of 7 days of long days at the end of your cycle is not affecting quality, not causing any sort of weird growth, but it's actually increasing yield. So that's something very interesting that I'm doing with a few commercial cultivators. We're going to start on the safe side, because the last thing I ever want to do is ruin someone's grow or cause bad things. So starting with a few commercial cultivators with varieties that they've got, months or years of data on already, together working and saying, all right, well, we're not changing anything but those last 7 days, maybe starting at 3 days, just to be careful, again, not to mess anybody's crops up. 3 days prior to harvest, you're applying long days. And what sort of yields can we get, and how does this work across different facilities? It's been proven on a small scale, peer review. I think this is a tool that we can certainly do together. So if you're a commercial cultivator and you're interested in kind of doing this work with us, really having a nice meta study, please reach out to me separately, because this is something I'd like to do in the next few months, get started.
I'd be into that.
Hey, Allison, how many extra hours are you applying in that last week from 12?
So it'd go from the 12 to 18 hours.
Okay.
Yeah.
Well,
So
I know
what we're saying, if you're going with some varieties will be okay with 2 weeks, but on a commercial scale, we're not trying to take risks here. But if we start with, do a few rounds with just 3 days, right? 3 or 4 days. Let's see what that increase is. Everybody's comfortable. And then let's go to 7 days and see, getting results from 5 to 15% increase in yield. Just depending on the variety and how many days you're doing it. So, tread lightly, but I think we can do it in a very controlled manner where this could be something that, is great across the board for everyone.
Do you think the yield increase offsets the additional power used and HVAC to control it and all that?
I think that's something to look at.
Yeah.
I think likely, if you're getting 10% greater yield, it most likely will cover those power expenses. But if you're looking at different types of facilities too, like a greenhouse, for example, if you're able to squeeze in extra light because you're probably already struggling getting enough light in a greenhouse, potentially, like if it's the winter months, let's just say, for example, that could be a really nice tool to bump you over the top.
For sure. Okay,
so that is all for the updates. I mentioned earlier, I want to start to have a focus on every call. We have great conversations, but sometimes we end up having one question on extraction, one question on fertilizer, and we just bounce around a little bit, which is great. And, I think it helps widen our understanding of a lot of different pieces. But I think to kind of help focus and narrow down what we're talking about, having a topic. So maybe it's propagation, maybe it's whatever. That'll allow us to dig a little deeper in what we're looking at. And I think that'll be beneficial. So for this week, or for this event, we're going to look at filtration. Now, filtration, why is that important and what does that mean? Because that could mean a million different things, right? It could be filtration for your employees that are in the trim room and they're not wearing masks and there's no filtration, right? You've got people dying and having really bad reactions across the board. We've got importance of our plants, right? If you've got particles flying around with spores hitching a ride and you're not filtering right, you're potentially causing a biosecurity problem in your facility. From a business standpoint, we've got to look at it as far as, well, we have to pass microbial testing to sell a product. So filtration is one of the few tools we have. But then in the states where there is crazy care about how it smells, specifically some places in California, they care about what's coming out of your grow or what's coming out of your greenhouse, and how it's polluting the community and what's stinky. So we've really got to get a handle on all these things and make sure we're optimizing. So it leads me to introduce this event's, we'll call it our vendor supporter. I want to introduce AAF, American Air Filters. And so they're one of the world's biggest air filter producers. Probably every air filter in your house, whether it says AAF on it or not, it is produced by them. And I'm really excited to work with this team because they're not just out there trying to push air filters. They're trying to understand this industry and understand, are we doing things properly? They're wanting to teach us. They're wanting to do group studies together. And so I'd love to let them kind of introduce themselves, and then we're going to run through some things we're doing together. Nikki, I see you right there. She's the scientist and the brains behind it. In their lab, they have their own scanning electron microscope, and I'm so jealous. But they have equipment to help us, and they want to help us, for free, to do things right. Look at air filters. You growers, maybe you're replacing air filters every 30 days just because that's what the box says. Well, why don't we do better than that? Why don't we send Nikki air filters that have been in our facility for a week, for 2 weeks, for 3 weeks, and let her look at it in her really, really badass lab and say, your filters are used up. You need to do this every week, just for example's sake. But that's the tools and the capacity they have to help us do it better. Nikki, take it away.
Yeah, hi. I think Kelvin's on the call too, but I don't see him here yet. But yeah, I'm Nikki Sasher. I'm the biological and gas phase lab manager at American Air Filter. I'm at our Clean Air Center, so that stands for Air Innovation Research. I'm actually in Jeffersonville, Indiana, and this is kind of our center of excellence, our R&D center, where we really and truly are a value add to every industry that we serve. And not only being, we want to understand the challenges that our industries that we serve face so that we can tailor solutions around your air quality concerns. And we do have all of those offerings available to be able to do the worker safety, plant health, environmental emissions, things like that with, a full suite of products and test services. So I'm the only microbiologist in the air filtration industry. We're the only air filtration company that has an in-house full-scale bioaerosol test capabilities, which is the capability that I set up here that I manage. And so I've kind of recently been named the U.S. bioaerosol expert, which was a little intimidating, but I'm figuring out how to use it. But anyways, I have the ability to do full filter testing on different medias, working with our design engineers to develop products and perform the testing on that, but also to be able to collect large amounts of data for a lot of our customers and industries, especially if it's a new industry that we're looking to understand better, to be able to more quantify how effective your filters are at removing your contaminants of interest, including your gas phase carbon filters. So that's one of my roles as well, is to be able to evaluate remaining life in your carbon-based filters. So I have full-scale capabilities, traditional molecular microbiology to be able to test for viruses, bacteria, and mold. And so, yeah, I've put out as we're trying to understand this industry better, we do service many industries, like I mentioned. One of the agricultural segments that we service is swine and poultry and animal husbandry. So they have a particular virus of interest. And when we entered that space, we wanted to understand that. So I put out a call for filters, even if they're not our filters, send them here to me at the Clean Air Center so that I could test the efficiency of those filters. I can challenge them with mold and be able to determine your removal efficiency remaining of mold. If they've been in the field for 30 days or 60 days or whatever, I'll be able to evaluate what that efficiency is as compared to what it was when you put it in service, if it was a MERV 8 or a MERV 13, which that stands for minimum efficiency rating value. So we're able to determine what kind of airflow you're getting across the filter, what your efficiency is of the filter, what your mold removal efficiency is of the filter, how well your carbon is holding volatile gases. And also too, just kind of be able to collect that data to know what these look like from different facilities at different time points. And so if something that you face is your filters getting gunked up from trichomes, like Allison mentioned, we have the scanning electron microscope here that we're able to actually even go even further than that to forensically examine the filters on the downstream side to be able to see what has gotten through the filter and is actually in the room with your process. So, be able to look at the fiber, see what kind of mold you might have growing on the downstream side or anything else is of concern. So yeah, I'm super interested in learning more about your industry. We really and truly do want to understand it and be able to partner with this industry for solutions. And so yeah, we have a video of where I'm at here that just recently was released. It's about 7 minutes long. I'll link it in the chat if you guys want to have a look at where I'm located. And that's a bigger picture of what our capabilities are here. But we really and truly can go from concept to commercial, to an actual like prototype within just a matter of days, from 3D printers and an engineering group here to make the filters, to be able to test them, challenge them with bioaerosols, the whole gamut. So it's a really and truly great value add service. And then, when people become our clients, then we're able to continue that with, ongoing support for whatever your concerns are of interest. So,
And also, I just wanted to jump in. Just Allison, just let you know I am here. I know you guys. I don't think you guys can see me, but I'm on. This is Kelvin. Can you guys hear me?
we see.
Yeah, we can
Oh,
see you.
okay. Sorry.
Yep. No, I was taking myself off mute. David.
Question. Thinking about filtration and categories of things that are applicable in this industry, because we have the volatile gases, terpenes, and then we also have molds, which are two very different categories. And then Nikki mentions trichomes. And I'm wondering if even trichome is an issue, meaning that it is still whole as a bubble, or by the time it reaches a filter, it is already ruptured and we're just dealing with the components that are in there. I just want to throw this out to the group for, we're talking about 2 categories, 3 categories, which are very different types of things you'd be looking to filter.
Sure. Yeah. And that would really depend. The volatiles are going to depend on, that's going to be a different type of filter. It's going to be carbon. The other things, the trichomes and the mold, depends on the size. Everything's going to be based on particle size fractionation and capture at certain particle size ranges. We typically test from 0.3 to 10 microns. Mold is in that range. And I assume trichomes are as well. I'm not familiar with those just yet, but I'm hoping to get much more familiar with working with Allison and doing some really important collaborative research with the CRC. And yeah, so that's just something we need to understand. I'm not sure how big those are, but that filtration would be a matter of particulate size, if that's what you're asking.
I was sort of looking for Allison's opinion. Would you expect to actually see a trichome as a particle, or at that time it has been disintegrated and it's the constituents of what made up the trichome after they've left the cuticle that are flying around?
I would think, especially in a spot where maybe you're making pre-rolls or, milling the flour, I would expect it could potentially fly up and out everywhere. And it'd probably be a mix of ruptured and particles and pieces and probably some, keef in the filters as well, would be my guess.
I would also be concerned with small leaf parts. So just general plant matter as a fine dust. In all my milling and sizing experiments, they were the most annoying. Like the green powder, not the white powder, the trichomes, but it's the green stuff. I have the problem, or we generally have the problem that the trichomes often are like more electrostatically charged and they stick to stuff more, while the plant matter does not have that benefit and sticks around. It's more agitated by air flying around. And so I do understand. Do I understand it right that Nikki, your filters do not handle the chemistry, so the terpenes and other volatile organic compounds?
No, they do. They do. We have that line of filters as well.
All right.
That's just our gas phase product
Okay.
line. Yeah. So those are our carbon embedded pleated medias and or filters with loose carbon in
Yeah.
them.
So
that's canisters and cassettes and all kinds of things.
yeah. So the volatile organic compounds, the VOCs. For that, I put a paper in the chat. There's a professor of atmospheric chemistry and organic chemistry. So she does like organic chemistry in the air. It's really cool. At UVC, so the university where my lab is. And she measured in various rooms in production, cultivation, trimming, and so on, the formation and therefore the load in the atmosphere of volatile organic or VOCs. And she found first temporal changes, which we're not really surprised at. Like when people work, more stuff happens, more's in the air. And the winner or the loser, however you want to see it, is trimming. So it's not the green, it's not the room where you grow the plant, it's where you trim them. So that goes then in David's direction, that maybe the trichomes or the remnants of them get exposed into the air, and therefore the VOCs are floating around. And so you might then use the filters on a more temporal basis. So you wrench up your air exchange and have maybe more filters in rooms where VOCs are a bigger problem, and you don't vent every room the same. So have a quick look through that paper. It's free to read.
Yeah, I definitely will. I definitely will. And one of our marketing colleagues is on as well, Steve Flores. He linked the video to that Clean Air Center in the chat. I saw it pop on, and I'll check out that paper. That's really that's good to know. Yeah, and I think as far as that discussion goes, it would be that the what the trichomes look like, and I mean, that's something that Allison and I definitely are going to be able to collaborate on, especially if I get a large quantity of filters in here from different areas of processing, and I'm able to forensically investigate those to see what we're seeing there, and we could collect some data that way.
So just to kind of add on a little bit to Nikki's point, so from AES perspective, obviously all of you guys are using various filters, and basically one thing that we've come across and kind of validated here is that pretty much every time you guys do a room change out from one cycle to the next, you're pretty much changing filters at the exact same time to prevent, like cross contamination, mold exposure, all these type of things, make sure the air quality is where it needs to be. I think one of the things based on AEF and the history we have, coming into this industry, we're, to Nikki's point, we're coming in to learn and really understand and ask questions. I think regardless of the history we have of the size of company we are, we don't know a lot about this industry. So leveraging Allison and coming in from that perspective has really allowed us to really be green, no pun intended, if you will, and really learn the how you guys go about your business. So we visited a few sites, and I think one of the things that's important to remember, pretty much any filter that you guys are using, we do have the ability to have a better quality filter to offer. But I think one of the things that we're doing before we go to that stage, we're trying to learn and understand first what needs to be offered, which is where Nikki comes in from the testing phase. And then on my side, I'm on more of the business side of it. Then being able to figure out how do we help you guys get a better quality filter that's not gonna break the bank, if you will. But I think the other thing is making sure that it allows you guys to have better quality overall. Because to your point, the post-harvest side of it, so the trim and the flower rooms, that's pretty much where we've seen a large portion of the filters are going to be needed. But I know that depends from one operation to the next, depending on the size of the operation, so on and so forth. So anyway, so like I said, I would say if you guys have any questions about any types of filters that you guys are using, there's a high probability we're going to have a filter that fits the specific need you're going to have. But we do want to get some of the testing out of the way first on Nikki's side, so we make sure we're offering you the proper type of filter, maybe antimicrobial, charcoal, vinyl filters, HEPA filters, whatever the case may be. So.
Yeah.
Yeah, and just to add to that, at commercial facilities, maybe not at your facility, but you've been part of one in the past where, you end up having a sales rep come through and say, here's this or that, buy it. It's going to solve all your problems. It's a Band-Aid to fix everything. And then it ends up sitting in the corner for a while. And that's because the creations are not purposefully made for the problem. And so what it gets me excited is, they're willing to listen and help us figure out the problem, because we don't know the problem yet. I mean, we basically know the problem. We don't know the details around the problem. So let's figure out those details and make a solution that works. So Carly's also a microbiologist. I'd love to hear what you have to say.
Yeah, me and Nikki are going to be friends.
Oh yeah, already I can tell.
So quick question. You guys are just making filters, not any device that is holding this filter or utilizing this filter?
We have both. We do have air cleaning devices as well. Yep.
Okay. I don't know if you see behind me, I am from Willow Industries. We do decontamination. So we kind of have 3 prongs where we decontaminate product, but we also do decontamination of your air. This is my I call it version 0.5 because it's my half-sized office one. But Allison and the team, you guys have quite a few of our first generation of our Willow Airs. And they really push some air. So I'm glad to hear that more air is good. We had some clients when they were first using them worried about how much air was moving. For me, air is good. Sounds like for the plants, more air, feet per minute is good. We use a simple 14 by 20 by 1 MERV 13 because we really have found that clients, as you mentioned, Kevin, that they want to change them often, but if they're very expensive, they won't. So we've kind of found the balance in the MERV 13s, but would be happy to talk about, what you guys have as options. We have many of these in the field. They're all collecting microbes, dirt, dust, and I'm sure we could work with some of the people that have them now and maybe get you some of those samples. And really would love to work with you guys. This is definitely my expertise.
So one of the things I would say about that, one of the things that we specialize in at AAF is the specifically high quality filters. And so when we say high quality, that means, for example, instead of changing that filter, I'm not saying this is going to happen because we still got to do the testing. So that's where Nikki comes in. But hypothetically speaking, generally, if you're changing a filter, let's just say every month, based on the type of filter we would provide, you would get a higher efficiency and you may change it out every 3 months, right? Because now it's the labor of that person having to go in and change out that filter. And it may be the same cost or slightly more expensive than what you're currently using. But overall, when you look at, well, I'm actually not having to change the filter as much, and I'm actually probably buying less filters on top of that, this is where it goes back to the quality of what you're buying. So because the feedback that I received when I went to MJ BizCon last year, which is actually where I met Allison, is basically folks are going to Sam's Club and Costco, essentially, and just kind of buying filters and just changing them out like that. And the reality is, to be completely frank with you, you're basically, you're buying the filter twice because we sold the filter to them to begin with. You get what I'm saying? So that's the flip side of it as well. But I think for us, the goal would be, can we get you a better quality filter that lasts longer so you can just spend more time focusing on the actual quality grow itself and not being so concerned with every time we change the room, we have to change the filter. But in order for us to answer that question, we need Nikki on the flip side to make sure we have the data to understand how much of the particulates can each filter actually hold. So then we can tell you if your filter is at capacity or not. Does that make sense?
That's perfect. Yeah. A lot of times we say that the filters are a collector, right?
Correct.
We want to collect and then remove.
Right.
Something I can give you guys a tip. When we sell our filters, happy to share info. We also supply a bag to put it in because we see a lot of people take their filter out, go down the ladder, go out the hall. And so we provide a bag with the filters to exchange your old filters, slip it in, seal it up before you even get down that ladder or, move an inch. So again, a lot of these like little nitpicky things that you guys will see in cannabis, the filters are in that room and you don't want to walk through that whole room. Again, why often they're changing it in between harvests or in between room changes as well, because that room is now empty. They can, get messy because they're gonna clean up. That's kind of that thought process for those time changes.
Well, and I think that's a good that's a good biosecurity protocol to have in place, just to make sure that you're not cross-contaminating anything by removing that filter, because there are some micron particles that come off of that and go straight into the airstream, that you can't even see. It just takes a couple of spores, so yeah, that's interesting. It's awesome. I saw you linked Willow in the chat, so I'll check that out.
Yeah, feel free to reach out.
But yeah, one of the things we're looking to maybe try to do with Allison at some point too is to try to do some in situ filtration studies as well to, try to evaluate efficacy of filtration, length of filtration, maybe try to standardize some airflows, try to, figure out what we can to, help write these filtration SOPs and create a little more standardization around what actually works, because we do have the capabilities here to fully evaluate that. So, yeah.
So I wanted to I'm gonna stop because Allison, I don't know if you want to jump in or not.
I was just gonna go with the people who have their hands up.
Okay, go ahead.
David, I think you were first in line.
Yeah, my question was about, for Nikki, Kevin, application-specific filters. So as it was stated, in a trim room, you have high particulate matter. Would you use one particular filter and apply it in a certain way than you would otherwise, let's say, in a grow room? And also the difference between makeup air, filtering it, where you're removing particulate matter from your outside air coming in, versus turning over air within a room without introducing outside air, where there you're just rolling the air in the room to scrub and clean up stuff that's floating around in the room. And is there, application guidance that could be specific to this industry so people know, hey, I'm not going to put the same filter same filter arrangement in my trim room that I would necessarily in a flower room or in a clone room, which have very different purposes and needs.
Go ahead, Nikki.
Oh, I was just going to say, I don't know that we don't have that industry specific information yet, but the more that we understand about this industry and learn about this industry, I think that we're going to be able to make some good assessments and recommendations on that, just kind of being able to see different setups in different states and things like that. But
Nikki, thinking back to all of the swine work that I know you've done, is there anything that maybe in that industry or similar industries where, there's zones of really high humidity or zones, are there differences that you find that, you're recommending different filters over the other, or is it purely based on particle size?
I mean, they're mostly based on particle size, but there are several that we have that are hydrophobic, that are water resistant. The pleats might be oriented different to run water down versus, sideways where it might sit in the pleats. We kind of determine that too, based on how caustic or what the environmental conditions are in that area. So with swine, that's just a really highly impactful corrosive environment full of hydrogen sulfide gases and extreme moistures and weather patterns, if they're in Minnesota or Iowa, and periods of freezing and thawing and things like that. So that industry typically has a 2-filter setup system where, they have their final filter, and then they have a pre-filter and that's usually for their incoming air. They have the pre-filter before it gets to the final filter, which makes their final filter last longer. And then they do the change outs on their pre-filters periodically. But, that industry is a little more standardized, where we know kind of when they need to change those filters out, just based on how corrosive their environments are and how filter components will degrade over time. So if a facility is more corrosive, if it's exposed to more moisture, more gases, more harsh environmental stressors or extremes in temperatures and humidity and things like that, then any filter, that's going to be a stressor on the components. And that market in particular may require a faster change out than say, a more consistent temperature and environmental situation.
So to also, David, I wanted to add to that. I guess I would probably say the easiest way to probably kind of answer that question is, in the U.S., obviously, different parts of the U.S., different types of environment. You have cold environments, warm environments, so on and so forth. The short answer is, I think there is going to be an opportunity for the filters to be different versus if you're kind of clean outside air coming in versus the inside air that you're kind of circling around. Because it's actually going to depend on where you are in the country. If you're in California versus if you're in New York City or New England, for example, it's going to be slightly different. So this is where, as we're kind of visiting different sites to try and understand how does the environment itself impact those specific filters and the buildup that will happen over time, because different things are going to be coming into your facility. And especially, as I'm sure some of you guys have already had some opportunities with, some of your neighbors, depending on where your building is, may be complaining about the smells and the scents, right, around the facility. So these are also things that for us, I would say prematurely speaking, without having official data on it, yeah, there's probably going to be 2 different types of filters that are going to be needed, but it's going to be concentrated based on where your facility is located and the area of the country, and the type of particulate matter and so on and so forth that's going to be coming in. So I guess that would be the simplest way for me as a non-science guy versus Allison and Nikki, answering the question. So
I was going to chime in too. I am also from AAF, Caroline.
I see you there.
Hi. I was actually a part of our sales team, but now I'm a market analyst. So just looking to learn more again about this industry, and then all the science behind everything in the lab. But what I was thinking of when you had asked that question, David, is that we would probably take a similar sort of approach or understanding to how we treat healthcare or how we treat a data center market. We treat the operating room in the hospital very differently than we treat the waiting room, right? So that kind of struck me the same way. And I don't know all the rooms that are obviously in the cannabis cultivation yet, and I'm looking to learn more about that. But I think we would treat it very similarly with our sales folks, our engineers, and things like that, because we do a lot of retrofits on the sales side that have to do with, your frames or your equipment. Like, you can make changes like that if you would need to, depending on what you want to put in your room filtration wise. So I think we have the capability to do that depending on what the needs are, like we do in healthcare and, semiconductor markets, data centers, everything like that. So just for some context, I guess.
Thank you, Caroline. That makes a lot of sense. Riley, I think you're next.
I kind of wanted to build on this conversation a little more about application specific uses, because I know that maybe an evolving thing in the industry beyond cultivation may be smoke lounges or consumption lounges. And I think there'll be a need for filtration, heavy filtration in these spaces. So I guess I'm curious if you've ever worked with the cigar lounges or something similar to that, with working with their air filtration, and if you maybe have something prepared for that.
Mm, so I guess I probably should have said this. So I operate specifically on the food and bev side of the business, not in the other phases. So as Caroline spoke, she actually has operated in some of the other phases as well, not only food and bev. So to answer your question about that specific aspect, that would not be, I wouldn't know the answer to that question. I don't know if Caroline or you or Nikki would be familiar if we've operated in that specific space before.
I'm not sure. I would reckon to that we have worked with the smoke lounge before, but what comes to mind is, again, back to hospitals with hospitals that have helipad areas or their ambulance intake area, smoke, smog from those areas, we assess differently, or, we filter differently. Also, places like gun ranges, we work with and treat differently. In relation to smoke, I would say casinos is probably, and it is a market we work in. We filtered it differently, and they want different filtration in as well as out. I would think, there's always a lot of smoke and things in casinos. So I think we've definitely dabbled in different variations of what you're trying to, I guess, what you were getting at with that sort of environment in a smoke lounge or something like that. So
we've done airports too. I'm aware that we've done airports.
Yes, and airports as well. Yeah.
Okay, that makes sense. I know that was, sorry, go ahead.
I was just going to say, Steve put in the chat that we've worked in airport smoking lounges, but yeah, that's what we were talking about. Sorry.
Yeah, I know that was brought up in Sacramento, California, when they were working towards getting consumption lounges. One of the main issues was filtration, and they were worried about standards of that, and if there was anything that was essentially going to be able to filter out those potential toxicants.
That's an excellent question.
Yeah, I definitely believe that we have products that target that particular problem.
Yeah, and I mean, when you look through their video about what they do, they've got these huge chambers that they can send fire or smoke down, and and see what it does. So, though they might not have the answer right now, they've certainly got the tools to.
Yeah, thank you. Can't wait to watch the video. Appreciate it.
Yeah, please do give us feedback if you need to, or feel free to reach out.
Murphy, what you got going on?
Oh,
hey,
sorry.
Riley stole my question. I wanted to ask about smoking lounges, but I have another question that I'm happy to throw in. And you guys talked a little bit earlier about, having some tools for determining when it's actually time to change that filter. And that's something that I think is extremely valuable and is actually probably the tool that you will need to properly answer for us what we need, because nobody goes through filters at the same rate. There's a lot of infrastructure reasons for that. Some people mix their dirt inside. Some people leave their garage bay doors open all the time. And in my experience, the people who change their filters most often are probably doing it more than needed in some cases. Whereas the people who really need to change their filters right now haven't done it in a year, and they wait until their whole condenser freezes over on their AC because the airflow is gone. And I work in, labs. I work in a lot of C1D1 and C1D2 environments. So it's extremely high airflow, which is also very hard on filters because, there's a directional flow and, some intentionally unbalanced force in that airflow. And so it's really hard to solve that filtration problem. And I think Allison brought up earlier, like the swine options. And I'm wondering, is there any tool that you guys recommend, or kind of what do you have in mind? Because, we can use a manometer, but it requires us to have a really good understanding of where that airflow is going, because where you measure with a manometer is as important as the measurement, and so where do you see that going in like a very tangible way for these growers to know, ideally without having to like get on a ladder? Because if I'm getting on a ladder, I'm changing it. Like, I'm not, you know what I mean? Like if I've taken the screws off of the holder, also, can we get like easier holders that are very swappable? But but, being able to, measure that in a way that, and I don't need like a $25,000 Bluetooth Wi-Fi dongle and, a CSV export to add to my to-do list. I don't want that. But, some kind of technical equivalent of like a reduction in airflow that it could identify and turn on a red light perhaps or something, like, is there anything you guys have? Because I know in USDA applications, there's a lot of like staged filtration because you have facilities that are like partially outdoors that we still try to filter. And so that's like a perfect example of hard problem to solve. So yeah, just what do you think? And if you don't have something specific, do you have any recommendations for how people can determine, have they used up their filter? Have they waited too long other than our air conditioners breaking? Because we definitely wait too long.
Where did you say this application was that you're trying to, you're just using a manometer to try to determine if you've got like a resistance?
Yeah, basically
less airflow.
Right. And so like in a C1D1 environment, it's real hard for me to get up in there and change it. In a grow, it's a little bit easier. But in both cases, I can't really check it unless I'm already up there. And so, that's not convenient for me. So something that I would be able to very easily and something that anyone can do, where they could just evaluate. Or is there anything we should be looking for? Because I can't tell you how many times I've seen an air filter come out with like holes in it.
Yeah. And once the pressure, once you get that pressure buildup, that does happen. The pleat tips can rupture and things like that. I've seen that a lot of times in the swine applications in positive pressure.
Yeah, they're concave sometimes, and that can't be right.
Yeah, no, that's definitely time to change it. But we don't actually sell any kind of equipment like that. That's like a portable, filter test rig or anything like that to be able to put in the field for you to test. I think that the answer to that question is probably going to come from being able to do things like it's not going to be an immediate answer, but it would come from something like being able to send me filters that I could put in here. And if you've had that in your C1D1 room for 30 or 60 days, and I can get a few of those and be able to evaluate the 30 to 60 day one versus, the 15 or 20 day or 6-week one or whatever. Then I think that would be valuable information to be able to tell you maybe like around a time point that might be a good preventative maintenance spot to just proactively change those out as part of your PM protocols. That's kind of what we've done with some industries too, is, help establish those maintenance protocols and things like that with when they need to change their filters out, based on a lot of the work that's been done here at the Clean Air Center, which we do have the manometers on the test ducts. Our test ducts actually mimic real live HVAC conditions, and they're standardized test ducts. So they have the optical particle counters upstream and downstream and the manometers to measure the resistance and pressure drop. So, if there's a filter that's significantly clogged, it's going to, definitely show on the data that we can collect there for efficiency, resistance, and pressure drop. And, if it came out of that area and we got, or, you could start sending me a few of them, just put where it came from and, date you put it in, date you took it out, I can run the test and I can start to combine that data, because ultimately what we want to do in this industry is, obviously selling filters is, our end byproduct, but we really do want to understand this industry and be able to become your partners and be able to answer these kind of questions through science-backed research, because other than a manometer or some type of airflow meter, like you're talking about, and learning how to use it, that's kind of, really kind of all there is other than sending the filters in to get tested.
Hey, if I can put a shipping label on that bag you provide with the filters, that's beautiful. I'm happy to send my problem to you. That's perfectly fine with that.
Yeah.
But I mean, it's a whole other job for me to do it, and it's not really a job I'm qualified for too. Right. So Yeah, I like that as an option, because I imagine you can see kind of the penetration through the layers to know, like, I would imagine in certain areas we probably would do better with, cheaper, thinner, replace them all the time. And in other areas, a more robust filter that can last longer is appropriate. And, to say for cultivation, this type of filter, and for, trim rooms, this type of filter might not quite be specific enough. But being able to tie that back to some kind of infrastructure.
Yeah, and your C1D1 room might be better to have a filter that's geared more towards, like Caroline was talking about, like fuel applications, because that's probably where the butane blast is happening, right? So that might be a situation
and
where
high
you want to,
humidity. Yeah.
Yep. So that might be a situation where you might want one of those power and industrial type filters that has a lot more surface area on the media, that has a lot of chemical resistance on the media and things like that, that can continue to maintain airflow without plugging up and stuff like that as often, because it's designed for that application of being around those gases.
Yeah. Well, and in those applications, in most cases, people have zero filtration, because any limitation in airflow puts you out of C1D1, airflow. And so now we can't evacuate flammable solvents. And so the compromise often ends up being to just not have a filter, which feels like not the right solution, but definitely the safer one. Like in terms of like particulate versus fire, I'll take particulate, but it's a bad game of would you rather. So, but I like the idea of being able to send it back to you, so that, because you'll know fully spent versus not better than us. I like that.
Right. Yeah. And this is going to be a long activity, to collect this data and be able to,
Oh, we'll fill them up quick. Don't worry.
Oh, well, hopefully we can get, some actionable answers and become all, you all's trusted partners in this, and, be able to work with you for your filtration needs, to understand the right products that you need for the certain areas, and be able to help you with airflows. And there was a question I saw in the chat about a UV light, that was why there's not a UV light adjacent to the filter with a vacuum blower to make this more sustainable. There's a study that's been done that I can send out to Allison or something like that, but really it's a standardized study that was done that with UV lights adjacent to air filters, and they can be put in combination with an air filter. They just need to be placed at minimum 5 feet upstream, because otherwise it completely degrades the filter components, and kind of renders the filter unusable. If UV light is too close to it, it degrades all the frame components and glues and everything. So that's why a lot of them are not used right adjacent to them, but they can be done 5 feet upstream.
I was also going to mention that we do have a tool called our TCOD, so like our total cost of ownership, where we compare filters, and we're putting in information like your unit's CFM, operating hours per week, per day, and then you're kind of assessing, how often are you changing it, and then we're using those specs from our initial testing with our filters, at the lab. What's their initial resistance and what is their proposed end of life final resistance? And we can compare our own filters to each other, competitors' filters to, to ours, and you can kind of see how it stacks up just with cost, labor, and disposal, all those things, but also kind of compare based on when you're changing it, is this filter's final resistance working within the time, you're changing it? So we do have a couple of tools like that we use to compare and sort of model, what different systems could use. So I don't know if something like that might be beneficial too, along with Nikki's testing, which will be way more specific to your facility and application. But at a high level, we do have a tool that does that.
Excellent information. Carly.
Did she disappear?
She disappeared.
I'm here.
Oh, there she is.
There you are.
We've also done some competitive research and development utilizing other filtration boxes that have R&D or that have UV lights in them. And for our microbiologists in the room, UV is not like an instantaneous thing. And really, they're just little lights that you're paying extra electricity for. Most of the UV lights that we've seen are like long tubular that are going like through the system of the HVAC. It is not, the addition of a UV light is not giving the value that a lot of companies are selling. So that's why we left it out. And we have a lot of people who ask, like, why don't you guys add? And it's like, because it's a worthless ad. And I don't want to charge you more money for something that's not doing its job.
Yeah, I would agree.
Awesome. It's great to get honest opinions. Very good. Oh my gosh, we're already at 2:04. We didn't even get to any of our questions, although I think we covered a fair amount of them. We're looking forward to putting together some nice cheat sheets for you all. Everything from, I know there's a handful of growers out there that don't even know what MERV means or not even heard of the word MERV. They're just kind of picking filters based on fitting the hole and that they need in their HVAC. So we want to put out some educational content of what these means, what it includes, thoughts about what you should be considering when choosing filters. Another thing we're doing is we're doing a large meta study basically where we are taking air quality samples from different grows from around the country in different areas. And so, for example, if you have an air quality meter at your facility, yes, you're checking your different areas and you can improve and, you can improve in those areas based on your numbers, but what's normal? What's normal? If I get, a PM1 of 2 consistently throughout my grow, is that good or bad, at least compared to the industry and where you stand on that level? And so, having that knowledge to make better decisions, say, oh gosh, we better get our stuff together and get these numbers down because there are successful facilities that do have better air quality. That's what we want to be able to provide back and say, this isn't the immediate fix right away, but here's where you stand and here's where you need to be thinking. Because, you guys know as well as I do, as people continue to die or get really sick, this is certainly something we need to focus on and pay attention to. So thank you so much for your time today. These guys are available via email. It was on the reminder email, but I'll also shoot out the recording, which will have their contact information if you got any more questions. But thank you so much for your time today. I feel like it was a great conversation with a lot of good information shared across the board. So thank you, and I'll see you in a couple months.
Thank you. Good to meet you all.